Morning students, today we'll be doing a little bit of translation, so let me write that down. The translation, where we will be using what is known as a translation vector. And basically, a translation vector is basically a type of transformation in mathematics that actually moves one image from one place to another in a Cartesian plane. Now, translation doesn't necessarily change the size or the orientation of the image, but it basically changes the position of the image. And the translation vector that we'll be using for today is 3, 1. Now we have a Cartesian plane here where we know that we have two axes, which are the x-axis which runs horizontally, or we can say from left to right, and the y-axis which runs vertically, which we can say from top to bottom or from bottom to top. Now we've been given 3 points here. So the image that we want to form is A, -6 to 1, B, -6 to 3, C, -2 to 1. And we know that all of the first values are actually the x coordinates, and the second ones are the y coordinates. Same with the translation vector. The first number is the x coordinate, and the second number is the y coordinate. So the first thing that we need to do is that we need to first plot our points. Point A says -6 to 1, so we need to find -6 on the x-axis and map it to 1 on the y-axis, so that would be about right here. And we call that A. B says -6 to +3, so from -6 we're going up to +3 in order to match it here. So B would be about right here. And C says -2 to 1, so we'll find -2 on the x-axis and 1 on the y-axis. So C would be about right here. And all that I'm going to be doing is that I'm going to be connecting my points now. So I'm going to use a straight edge and connect my points. Now my points are connected. So when I use the translation vector to transform this image, the size of the image should remain the same. All that should change about the image is basically the position that it is. What the translation vector is saying is that for each point, we need to move it 3 places positively on the x-axis and 1 place positively on the y-axis. So if point A is here and point A is at -6, the new point needs to be 3 places positive on the x-axis. So the x-axis is going like this because it is horizontal. So what we're going to be doing from A, we need to move 3 places to the right because it is positive. So A would be 1, 2, 3 places. So A will basically fall right over -3, and it says that we need to move it 1 space on the y-axis positively, and positive on the y-axis is going up. So it will now move from 1 and it will go to 2. So the new point for A would be right here, and we call that A prime. Same thing for B. For B, B is already right here, and we need to move it 3 places positively on the x-axis, and positive is moving to the right. So B is at -6, so B would be 1, 2, 3. B will now be at -3, and we need to move it 1 space going up on the y-axis. So therefore B would fall right over 4. The new coordinate for B would be there. And then we do the same thing for C. From -2, C needs to move 3 places positively on the x-axis. So C needs to move 1, 2, 3. So now we'll be at +1 and 1 place on the y-axis, which will fall right up here. And all we're going to be doing now is that we're going to be connecting our points. We use a different color. So basically all we need to do now is that we need to connect our points. Bam. 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 And if I was using a proper graph board, you will realize that basically none of the size of the images formed changed. The only thing changed is their position. Because the first image was here, and the new image formed will be right here. So then again, all that we're doing with the translation vector is that we're taking each of the points that we plot and we're going to be using the vector to tell us how many spaces we need to move either left or right on the x-axis or up and down on the y-axis. Thank you.